Okay, great. So thank you all for coming to our seminar series. It's a special one this time. I'm very excited. First, actually, I need to tell people at home that there will be sound played here. And so apparently Zoom is really bad at filtering. Actually, it's good at filtering sound. So if you want to attend the seminar and actually listen to music, you better go on YouTube. So if you can switch to YouTube, you might actually get the full experience here. And so I'm very happy to introduce Chris. Luna Mega is a colleague of ours from the music department at San Jose State University. And I have some information about his career. He's a composer from Mexico City. He's interested in focused listening, performance strategies, audio technology, and interdisciplinary collaboration. His work analyzes sounds and data from natural and urban environments and translates them into notated music for performers and electronics in various forms of media. His music has been featured in festivals such as Other Minds, The Nature of Music in Berkeley, Differential in Mexico City, the New York City Electroacoustic Music Festival, Seoul International Computer Music Festival, Angelica in Bologna, which is actually my alma mater, Tectonics, Reykjavik, Tectonics, Glasgow, Love, Montreal, Avant X, Toronto, among other places. So his research on acoustic ecology and environmental sound-based composition has been presented and published in the Proceedings of the Computer Music Multidisciplinary Research Conference in the Jefferson Journal. He's an assistant professor in composition and electronic music and theory at the School of Music at San Jose State University. And I must say also that we recently started a collaboration, which I'm very excited about sound in beaches of all places, and probably will go beyond that, and we'll, we hope to see him here more often in the future. But please welcome Chris.
Thank you. Thanks, Ivano, for the introduction. Hello, can you hear me in the speakers? Is it coming through? Check. Oh, it's okay, I see. Oh, got it. Oh, it's fine. Okay. Yeah, I mean, I hear myself. Yeah. Well, thanks for having me, Ivano and Moss Landing Marine Labs. It's a pleasure to be here to discuss work that I'm doing in the dividing line between science and music. This is something that I've been interested in, I think, probably since I began making music, when I would just be in nature, and I was like, I really think there's nothing more perfect than this sound. Like, I'd rather this sound over any other sound, like listening to the sound of a stream. That did it for me. I started dreaming about how can I actually make music that would be very, very intimately connected to this, not based on it or inspired on it, but intimately connected to its structure. And this is something that, I'm not a scientist, but I'm imagining that you can have some understanding that is deeper than mine in terms of, okay, how do you actually access the structure of things, right? And so this started my journey of making music based on the environmental sound. And so I started recording just sounds of, actually it all started with a recording of the sound of a stream. And I remember, like, my roommate back in the day thought I was crazy because, like, he would just hear me listening to the same bit of audio over and over and over and over because I was transcribing it. I was trying to listen to it and to hear, okay, what pitches are happening in the stream. But as you hear the ocean, for example, the ocean is highly chaotic in its sound, right? I mean, even when we hear patterns of the waves breaking, there are a lot of variances and a lot of subtleties. So anyway, that started my journey, and then I started being interested in using technology for aiding my compositional process, which is highly related to transcribing things. And so through sonograms, spectral analyses that you can run audio, like sound, and it gives you like really like a visual representation of that sound. I started doing more accurate transcriptions of events, like sounds of crickets in the forest, or like a geyser that I recorded in Iceland, or ocean, like the ocean, the breaking waves of the ocean. But then it started dawning on me, like, okay, this is all data. Like, sound is data, basically. Like, music can be all quantified, right? So if you think of pitch, we're thinking about vibrations per second. Like, if I sing, ah, let's say that is an A in the third octave of the piano, that would be a certain frequency, but it could be 260 hertz, let's say, and 260 vibrations per second. So everything is quantifiable, like pitch, volume, you name it, of musical parameters, density, texture, timbre. All of these different things that are very musical can be quantified. So I started thinking, well, there's a lot of potential in using data from other fields that are actually doing like a very profound study of natural events. So this is one of the projects that I've worked with that has mapped data into sound. This was a collaboration between Stephanie Rowe, who is a IPCC lead author, or she has been. But back in this time, she was very involved with the IPCC, working especially on a publication on the strategy of increasing forest cover. And this is what this means is really pushing for policies to change the policies of land use and preserve forest cover, and expand it as a climate change mitigation strategy. So we got together and we thought, well, let's just think about a few variables that we can think about, and let's try to make your research sound. You know, like let's make all of this research that you're proposing sound. So we started just getting deeper into it, and so the idea was that she was going to run these tests with Earth system modeling. So what this was, like, she went to Boulder, Colorado, to this institute, NCAR, and they have this very powerful computer that can create these scenarios based on current biophysical and sociopolitical realities. Because of course, like the idea of forest cover and changing land use policies, they're not only about the biophysical realities, but also sociopolitical. So this computer kind of takes all of these things into account and creates projections of, okay, like in the next 100 years, what is going to be the situation. So with this idea, there were two main scenarios that we decided that we could use as the foundations for this sonification. And so this is the first time I use the word sonification for you in this talk. Who has heard this term before, sonification? Okay, so what sonification is basically and purely, it's the translation of data into sound. That's what it is. And I'm going to show you a couple of instances. In fact, the piece that I'm going to present for you today, it is a sonification. It is turning data into sound. So we thought, okay, let's use this data to sonify two variables, or two scenarios. One is a greener world scenario in which, through forest cover expansion and preservation, there's only a 2 degrees Celsius increase by the year 2100. And then there's this other scenario, which is the business as usual scenario, is what she called And I think it's kind of like consensual in at least in her field, but I see Ivano nodding, like probably it's in your field as well. So that's the worst case scenario, like a 4 degrees Celsius increase, which maybe has increased lately, because this piece was from 3 years ago. But so the idea was that through music, we could convey this research to broader audiences and to try to help the audiences connect to this research from a more, let's say, perceptual and maybe sentient perspective, like not only a rational one. So we had the notion of, okay, let's work with a few of your variables. And this was a long process, because let me just go to this slide. So this is where it started. Like, she just told me, okay, so you want to see my data here. I can put something very simple for you to look at. And so she gave me this first spreadsheet, and this is kind of how my workflow usually looks like when I'm going to sonify something. I use CSV format spreadsheets, and I derive graphs to start kind of getting a sense of what the trajectories look like. I mean, as soon as I'm looking at those graphs over there on the right, I'm starting to get a sense of, okay, what could they mean in terms of music? But so as far as the variables that Stephanie Rowe gave me, the ones that made it to the short list, let's say, were forest cover, total ecosystem carbon, the mean surface temperature, the evapotranspiration, and the albedo. So albedo, it turned out to be one of my favorite kind of data to sound mappings. I'm going to play this in a little bit for you. But the trajectory was a very interesting trajectory, melodically speaking. So we were thinking about, okay, so what can we do with these? And you see the orange and the blue coding for the graphs. The orange coding is the business as usual, and the blue is the greener world. So the orange graph, like you can see, sorry, the other way around, sorry. So the orange is the greener world, and the blue is the business as usual. In the greener world, you can see how, there's a significant increase in the forest cover starting around year 2000, I can't see from here, but like 2010, 2015, and it starts ramping up. And then the business as usual, we just continue in this decline of forest cover in the world. And so we have these two main scenarios that I wanted to convey musically. And I'm going to talk a little bit about how that can be a challenging thing. Like, how do you think about, okay, how can you convey a scenario in which things have kind of improved or things are going a little bit better? And how can you talk about, how can you musicalize a scenario in which things are kind of going downhill? So we ended up choosing these variables: forest cover, evapotranspiration, mean surface temperature, and albedo. And in the end, the trajectories look like this. Like, this is the final, this is a snapshot or a screenshot of the project as it was finalized. So this is the business as usual scenario, and I'm going to play a snippet of that. So in this case, this is a translation for piano. So this is a rendition in piano. and synthesizers. So before I play this, I want to show you a little bit what to listen for. So the piano is, you can see the piano in this graph. And so as the piano goes up in pitch, you're going to see the graph go up in pitch. As it goes down in pitch, you're going to see the graph go down in pitch. So the piano is following the evapotranspiration graph. And the albedo is one of the synths. It's the left side of the speakers. And then the forest cover is the right side of the speakers. And then you're going to see an acceleration of the tempo. So, and the piano is containing the tempo. The tempo is the beat. So I think this is the beat right now. Let me see. Right. So as the forest cover declines, you're going to see the graph drawing as it's declining. The tempo is accelerating. And this was one of the conversations I had with Steph Rowe. We were thinking, because originally we were thinking, okay, as the graph declines, the tempo declines. But then we were like, no, actually, what happens when a system is in, or like a human or any living being that has a heart is in a state of stress? Like the heartbeat starts accelerating, right? So we decided that as the forest cover declines, the heartbeat would be accelerated. So the tempo is accelerating. So in 2020, there's like a regular, like kind of like a moderate tempo beats, BPM, as we are approaching 2080, 2095, the tempo is way faster. And then lastly, the mean surface temperature carbon emission sounds, you're going to hear as the years go by and the temperature rises, the carbon emission sounds increase in the mix. So first we hear actually more sounds of wildlife. We're hearing, like for instance right now, I'm going to play a little bit and notice a few things, like notice the tempo, notice the sounds of the wildlife, basically that. So this is the general tempo that you could perceive now. So let's fast forward to let's say 2080, 2075. By the way, I just want to share a little experience I had while I was about to perform this piece not too long ago. I was in the concert hall, just like testing the sound, like hearing like the sound coming out of the speakers, me playing the piano. When I hit around this time, this moment, I just felt this kind of very intense sadness. Kind of like just thinking about like, okay, that year I may not even be around, you know, and you know, we're thinking about like a very grim scenario and so on. And I mean, it was very intense. It was like one of the intense moments in my life. I mean, I had to stop playing for a little bit. But this is something that I hope that can really be a result of this music, that it can really convey those areas that people need to understand a little bit more from a more, let's say, felt perspective. Of course, I'm going to show you the greener world scenario too, so it's not, you're not going to just keep the the grim part of the story. This is the business as usual, I insist. So continue trying to do this exercise of following what you hear with the graph. Like the piano is probably the easiest thing to follow, because as it goes up, you can see the graph go up and down. The synthesizers, it's the same case, but they're not as easy to discern as the piano. And now listen to the tempo. The tempo has already increased by a lot because the forest cover has decreased considerably. And now listen to the mean surface temperature data, which now the carbon emission sounds, we're going to hear way more of post-industrial revolution sounds now, and way less of nature. Actually, there's no sounds of nature at this point. So the process of the mapping of this data, it's very simple in terms of the translation from the data set into the sound parameter. So you can see here we have the 4 variables: forest cover, evapotranspiration, mean surface temperature, and albedo, the 4 columns. And the main, let's say, the main concept that is used in the mapping is establishing the lowest and highest values, which you can see the data variables. In the case of forest cover, the lowest variable is 34.19 millions of square kilometers, and the highest is 37.26 millions of square kilometers. Or like in terms of temperature, the low is 9.33, the high is 15.80 degrees Celsius. So if those are the lowest and highest values, then the mapping to music, that's where the composing comes into play. Because then you think about, okay, first, what kind of parameter of music am I going to be using? Am I going to be using pitch? And that's kind of like the go-to. That's like most sonifications that you find. If you Google or YouTube sonifications, like NASA has a bunch, for example. Like if you go to NASA and look for sonifications of NASA, most of those sonifications will involve pitch and density. They're thinking about, you know, like nebulae and also like movements of patterns in the heavens or in space. And so texture, so density and pitch, those are the most common ones, but there's so many others. So the ones that I focused on were pitch and volume. So volume is for mean surface temperature. You can see in the third column of mean surface temperature, in the music parameters, you see minus 20 to 0 decibels. That's our measurement for volume in music. I'm not going to get into details why minus 20 to 0, but that's a convention. Like 0 is the highest possible volume that you can get to with electronics, but for peaking and distortion. But so in musical parameters, for instance, we look at the part that the piano plays, evapotranspiration, that column. The lowest pitch of the piano is a G2 in the keyboard, and the highest pitch is a G3. So it's an octave. It's really just from G to G, an octave. And of course, I'm doing other things on the right hand, kind of to harmonize those pitches, but really the foundation is from G2 to G3. And we also have a minimum value and a maximum value. So with a software that I use, that I'm going to demonstrate in a second, that mapping takes place. It has to do with scaling of the data. It has to do with, okay, scale 33.50 to 37.77, the values of the data set, evapotranspiration, map those low, high values to sound low and high values, which are 98 and 196 hertz. So this is how the software looks like, and basically, I'm going to show you the actual patch. So my students always get a little horrified when I open it up, because right here it's like, okay, this is welcome to my room, right? So let me open the closet a little bit, and in this case, I'm just going to show you this over here. I'm going to zoom in a little bit and show you how the workflow goes. So we have the main thing, like what drives the whole thing, is this object that contains all the data points. So all the data points go here, and they are sent to this scale object. We call these objects, or like they're a replacement for lines of code, let's say. And so what this object is doing is taking the lowest and highest value of the data set and mapping it into the lowest and highest value that I want it to go in terms of sound. So we have one value here, another value here, then one value here, and another value here. So that's what it's mapping it to, and it's outputting it into sound over here. So I want to play a little bit of, like individual variables. And an important thing is, how fast do you want to, do I want this to go? Like in this case, I selected for each of the years, each of the movements from one data point to another, therefore from one point of the sound to another, to happen at a 5-second interval. That's a pretty long time. So in the original piece, I'm going to reset this to the business as usual. In the original piece, I have this going at 500, well, sorry, at 5 seconds intervals. I'm going to reset this. And I'm going to just play the albedo. So you see, here's year 2001. Now, as soon as it changes, the data is going to start moving in a sec. So now you're going to see changes at every year change, and you see the value here. So this is what ended up being the piece, but it could have been a very different piece. For instance, you know, this is where composing comes into play. Like some people think like, oh, sonification is not composing, but really it is as compositional as making a piece with let's say, traditional harmony. So I'm going to stop this for a second and change the speed, the rate of change from data point to data point. So I'm going, instead of doing it every 5 seconds, I'm going to do it every 1/10 of a second. So the piece that we heard, it evolves over close to 9 minutes. So the whole reading of the data. Now we're going to have the whole reading of the data probably like in a few seconds. So now second cycle is starting. So it's already in the second reading of the whole cycle. So it would be a completely different piece. Like I'm more drawn to doing something like this now, like kind of like a polyphony thing, like kind of like a fugue with this theme of the data, and just there's so many ways in which we can work with it. Let's hear. Let's hear temperature. This is the most obvious one. You would expect that, right? Just like an ascending line. So anyway, this is the way the patch works. So I want to show you now a little bit of the logistics around performance. So this is, let me go back to here. So this is the conversion of what we heard into the sound. So this is for the greener world scenario. This is the notation for the cello. And so you can see every 5 seconds there's a change in the pitch. So once you have the data mapped into sound, it's a very simple process to make a score for the performers. And I want to show you the greener world scenario. This is another part of my workflow here. This is my file. So remember, you probably remember well the end of the business as usual piece. So here's the difference between that and this. This is a piece, the greener world involves more instruments. Instead of it's not as electronic and digital as the business as usual. I wanted the business as usual to feel arid and computery and dry and kind of like, let's say, what would be the word for it? Like, someone said ominous. Yes, ominous. Yes, exactly. Orwellian. That's a great one. And this one, I mean, I still didn't want it to feel like, oh, it's like we're going to a Walt Disney World, right? And I wanted it to depict a little bit of, still, there's gravity in the problem, but it's not as grim. So let me play this. And so therefore I chose more instruments. Like cello is one of the important instruments. Like actually it's the main instrument here. And percussion, like a real percussion kit with Korean gongs and with omglockens, which is like a beautiful wooden instrument which creates a certain pitch, and then tam-tam, which is like this big, beautiful, you've probably seen it, like it's like a gong, but a big one that creates this like this very big, noisy, but yet a little bit of pitchy sound. So now the process is different. Like in this case, the tempo, I'm going to play it from the start. It's still this sense of urgency at the beginning. Fast tempo. So in this case, the cello is doing the albedo. So the cello is doing pizzicato, like a very rapid pizzicato with a high sense of urgency. The gong is doing the tempo, which is like that. And so fast forwarding, and also, of course, like there's sounds of more industrial sounds in the beginning, but then as the piece ends, as we see a reforestation take over, and the variables like temperature and albedo and so on, I mean, they don't get much better, but this is actually how they look like. Oh, hold on. Where's the movie track? Oh, here it is. This is how the variables look like over here. So Forestcover, very obviously going up. But you see the albedo is not that different. It's a little bit different from the business as usual. Mean surface temperature kind of stabilizes at the end, like towards like 2080. Evapotranspiration. There's slight changes in these three. The only one that is obvious is this one. So, however, the important one is Forestcover. So we have more of natural sounds and a slower tempo in this side of the piece. And a very melodic cello. You also heard the violin, which is doing the Forestcover sounds as well. It's ascending in pitch. The cello is doing the albedo. The piece doesn't change much as it goes to the end. I wanted something neutral. I didn't want something that was like necessarily happy. And neither did Steph Rowe, because we didn't want it to be like, oh, like this is the happy and this is the sad scenario. Although, you know, I'm very in like a specific kind of musical practice in which my perspective of what is neutral, what is sad, what is happy, what is consonant, what is dissonant is very kind of already biased in my own world. Like when I show my parents, oh, this is just very neutral, they say, no, this sounds like horror film, you know. And so, I mean, I don't know, when I'm saying neutral, I hope, you know, you agree with me, but if you feel like it's horror film, you know, it's fine. But anyway, so that is the business, I mean, the greener world scenario. And for the cellist, it's very difficult. For the performers, it's difficult to keep the tempo difference because the tempo is constantly moving. So they need a click track. So I'm just gonna, this is the last thing I wanted to show you. They need a click track. Any performer who is playing sonifications that deal with tempo and that deal with like very precise tunings, like the cello is doing something we call in music microtones. It's the tones in between, like the white keys and the black keys of the piano that we just don't have in the Western tuning system, but there are in nature all over the place, of course, and in other musical systems. So anyway, I'm going to show you what the cellist had to listen to while he was recording the piece. So it's the original oscillator. He's tuning to this as he's playing and following the tempo. Of course, reading a score. I fast forwarded slower tempo now. Fast forwarded slower tempo. So as a reference guide, because otherwise, if I just give him a score and tell him, oh yeah, go from this tempo to this tempo over the next 5 seconds, and then to this tempo, like it just doesn't work. It requires all of this kind of backstage tech for the performers to be able to be true to the data when they're performing it. So I think in order to leave 10 minutes at least for a discussion or questions that you may have, I'm going to leave it there. So yeah, maybe should we brighten the room a little bit and have a thank you. Thanks. The microscope, that would be fun. Yeah.
Thank you. That was to repeat it for the people online. That we're used to looking at data and patterns visually, but I've never actually thought about putting it to sound. So that was a really interesting transition or new view. Mm-hmm. Some of it's your interpretation of what a sound would sound like, right? So that was, I'm interested in you talking more about that. But in applications, I can see, like, looking at fisheries, one of the things that jumped out, not just temperature, but fisheries declines, yeah. And then, you know, the rebounding. Could you see something like that in other applications that you've thought about applying this to?
Well, first, thank you. I appreciate your thoughts. And when you ask about other applications, do you think is it referring to other areas of let's say of data, like other sources of data?
Yes.
Oh yeah, absolutely, absolutely. I mean, the first example I can think of is the work that Ivano and I are considering collaborating with, which has to do with doing this with his research on marine geology. So I would be very interested in just tracing, thousands of years of coastal change into sound. Like we're actually expecting to get some money in order to have that piece performed with a really good ensemble in San Francisco, using that data set. I mean, we're knocking on wood that we can get the funding. I mean, it's going to happen at some point. But yes, that would be one thing that I would like to be doing, and that's the most immediate one. Yeah.
Thanks. Super interesting. I'm interested kind
Thank
of on
you.
the same line as Diana was talking about how you make the decisions, because obviously how, like you showed that the decisions you make about tempo and speed and all of this make a huge impact. What was that process like in terms of collaborating with Stephanie Rowe, in terms of, because how you presented and even the images and the sounds of the nature and the industrial sounds, that all impacts how people are their emotional response to the data. So I'd love to hear a little bit about what that looked like.
Yeah, well, thanks for reminding me of that component of the question as well. Yes, I mean, it was crucial to have Steph Rowe's ideas about this because, as I said, I'm very entrenched in my own, or not entrenched, but I live in my own like musical world, right? And having her ideas really made the piece be a little bit less, let's say, experimental, avant-garde niche. Even when it's still a little bit on the experimental side, she would be telling me things like, okay, let's try to do something that sounds a little bit more melodic, for example. Like let's have sounds be. Is there any way that we can have some harmony? And so that's kind of like what ended up happening when I added these chords in the piano, for example. The piano originally was just way starker. It was just like these these one pitch sounds. Like then, based on her idea, I just like said, okay, I can add some chords to this, like kind of add from the actual data sound, but like create a chord for it. And then for the Greener World sonification, I definitely did my best to kind of massage the data, to put it some way, which is basically a mapping thing. It's not that I changed the data values. It's just more like I really tried with the mapping to create a harmony between the cello and the violin, and even with the chirps of the sounds of nature that were happening, like to create like something more consonant, like as consonant as I could. So I think if we had not had those conversations, that wouldn't have happened. And she was very interested in, like, when she presents her work and she presents the music to the people that she's talking to, that she can really establish the difference between, okay, this is the business as usual and this is the Greener World, and this is very clearly differentiated. And like, the first one is dissonant and Orwellian, and the other one is more consonant. Just, that was like the main thing that she suggested, and I think the piece would have been different without her suggestions. And this is what makes it so interesting to have someone from the actual field doing the work, giving input on the composition.
Yeah, that was pretty interesting. I've never even thought of anything like that. We go through a lot of data here, and that would actually probably de-stress a lot of people if you just listen to it. My mom was really big into like opera and classical music, and when I was kind of listening to your stuff, actually I kind of heard Holst the Planets. Is that something you're familiar with?
Yeah, totally.
There's Mars and Jupiter and all that.
Yeah.
And Mars is very like, that would be the perfect, end of the world scenario.
Yeah.
That song. But anyway, I didn't know if that was you have that kind of background or anything like that was going into this.
So some of this music reminded you of Holst?
Well, actually, the more ominous one was like the last 10 minutes of Halloween, the original, you know, dun, dun, you know, when Michael Myers comes after Jamie Lee Curtis, dun, 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 you know.
Yeah.
Anyway, my
Yeah.
mind was going, I mean, that's the thing about music, right?
Yeah.
You can totally put yourself where you were 30 years ago when you hear a song, right?
Yeah.
And so I think it is powerful in that sense, is that people will, like, every time they do something crappy, they'll be like, ooh, I remember I heard that really horrible pitch that I didn't like, and that might result in something. And so it's kind of like subliminal, and I don't know if that's kind of your,
Totally.
if that's some kind of a result too, kind of give a subliminal kind of a reminder. Because I think we just forget, like we go through our daily life, and we're worried about whatever. And
Well,
so,
I mean, thanks for that, for the notion of that. I mean, you know, for me, more than subliminal, it was something like, you know, because subliminal is like more on the subconscious level. And I was just thinking basically in the conscious level, but if it's actually doing that other thing, which actually music does, and like probably like all other, like smell and then.
you hear a song that you haven't heard in a while, and you can remember exactly where you were.
Right. Yeah. Yeah. It happens with smells and with textures and so on. But yeah, I mean that's a great point, and I'd love that to be the case. I hope that is the case with this music. I think that would be great. And yeah, I have a background in classical music. I mean, before I got interested in all this, like I studied Holst, I studied like, you know, Strauss and Beethoven, and you know, that was the orchestration that I learned. So maybe somehow it's bleeding into this in a way.
Really interesting.
Thanks.
I think you're probably looking at data that's been averaged over the entire globe, which makes the climate signal come out really clearly. But if you were to look at, say, the model in just Northern California, there'd probably be a lot more chaos and weather, and
Right.
that's kind of more of our experience of, you know, we have all this variability, but then climate is this subtle signal that becomes more apparent over time. Do you think that would even be feasible to look at a single location with all that chaos, or would the
Would be
musicians just walk
fascinating.
out?
It would totally be feasible. I mean, it would not be for all ears, you know, like, you know, I think that, I mean, I would love it, you know, and like to have like some sort of like spatial distribution of like the sources of sound, because, you know, if it's all coming just from a stereo field, just like from left and right channels, which is what we heard, you know, it can get pretty muddy, because if we have like, you know, like the localized, you know, let's say climate patterns of different areas like California, and then we have the East Coast, and then we have like Africa and Asia and whatever, it would be very different in each location. So maybe have it like in a space, like I see like 4 speakers here, like imagine 8 speakers, and each of those speakers having like one of those things. I mean, it would be pretty crazy sounding. I'd be totally down. Yeah. Yeah, that's right.
Thank
yeah.
you.
Yeah, that's a good idea. Thanks. Thank you. Thank you all.